Okay, for this video, we'll be going through pure physics energy chapter. Okay, success criteria A, show an understanding that there are energy stores. Later we'll go through the stores, and then we need to know the pathways. So basically, these are the pathways. Okay, we'll also be going through in details. Now, basically, what is energy? Energy is required for things to do work. Okay, so this is the definition. The SI unit for energy is joules, Joule, capital letter J if you are using the symbol. Now, what is energy store? Okay, it's actually a system consists of different parts working together. So gravitational potential store of an object is actually an energy store of the object and Earth system. Okay, so when we refer to the gravitational potential store of the object, Earth has been considered as a part of the system. Now we have 6 types of energy stores in our syllabus. So the first one is elastic potential store. Okay, so example, a stretched rubber band or compressed spring will have energy in the elastic potential store. Okay, then is the next one is kinetic store. So any object in motion, that means when they are moving. Example, a rolling soccer ball or spinning frisbee will have energy in a kinetic store. Okay, we used to call them kinetic energy. Okay, then next is the internal store. A hot object such as hot metal or hot drink has energy in the internal store. Okay, we used to call them internal energy. So this energy in the internal store is like all objects, they will have it. Okay, so in our syllabus, we focus a lot on a kinetic store because there's calculation involved. Okay, next is gravitational potential store. An object such as a book above the ground has energy in the gravitational potential store. So it's basically due to the position above a certain height. And we also focus a lot on this, okay, EP, because it involves calculation, right? Then we have chemical potential store. So it comes from the food that we eat. Fossil fuels and batteries have energy in a chemical potential store. And lastly, we have nuclear store. So the nuclei of atoms have energy in the nuclear store. So nuclear energy, this will be covered in Sec 4. Okay, so what is energy transfer? We can think of energy as a non-physical and invisible substance that can be transferred from one energy store to another. So the total amount of energy remains constant. Now there are 4 different pathways as to how energy can be transferred from one store to another. First one is mechanically, by a force acting over a distance. Okay. Second is by heating. This is due to a temperature difference between the 2 objects or the 2 stores. Then propagation of wave, both electromagnetic and mechanical. So we have mechanical like sound wave. Okay, electromagnetic, we have light wave. So last time we used to say that talk about light energy and sound energy. Take note that now we do not refer them as light energy and sound energy. Okay, so the light and sound, they are now known as waves, or they have always been known as wave, and all these waves transfers energy. Okay, next is electrically, by charges moving through a potential difference. Okay, so basically there is no more electric energy as well. Okay, so electrically, it is one of the pathways that energy is being transferred. So let's take a look at more details. Now, energy transferred mechanically by a force acting over a distance. So example, a force is applied on a cart originally moving with constant velocity over a smooth surface. So smooth surface, there will be no friction force. Okay, so in part A, this is the direction of motion of the object. From left to right, moving at a constant velocity of 1 meter per second. Okay, then we apply a force and the object actually moves faster. Okay, so now moving at 2 meter per second. So the resultant force actually caused the car to accelerate in the direction. Okay, so before the force is applied, the system or the cart has energy in its kinetic store. Okay, the energy in its kinetic store is represented by 1 unit. But why is it that it's 1 unit? It's just an arbitrary number, so this is just a model, okay, to show how the energies are being transferred. So this is the initial amount of energy before the force is applied. Okay, this is the energy of the energy of in the kinetic store of the cut. Okay, so it's a mouthful, but you have to write it in such a way that it is the what kind of store of the object. So that means the store must have an owner. In this case, the owner is the cut. The cut has energy in a kinetic store. Okay, so we input 3 units of energy, okay, and it's transferred mechanically by a force acting over a distance s. Okay, so this 3 again is an arbitrary number. How do we arrive at this 3? Just a model. Okay, so 3 is added in. So as a result, the cut, which is the object, which is the owner of the kinetic store, will now have a total of 4 units in the kinetic store. Okay, so after the force is applied, the energy in the kinetic store increases from 1 to 3. Okay, so now represented by 4 units. The increase in the energy is due to mechanical work done by force acting on the cut over the distance s. Okay, and because there's no friction, because it's a smooth surface, energy transferred out of this system, the cut basically is 0. Okay, so we need to talk about the pathways. When they ask you to describe how energy is being transferred, you need to talk about the pathway. You need to talk about the store in which the energy is being transferred to, and you need to talk about the owner of the store. Who owns the store? Okay, yes. Okay, let's move on to the next example. Energy transferred by heating due to a temperature difference. Okay, so block of butter initially at room temperature placed on a pan, okay, on an electric stove, and is heated up. Okay, the transfer of energy is due to the temperature difference. So this is the pathway between the hot surface of the pan and the butter. So before the stove is turned on, the butter, which is the system we are talking about, has energy, okay, in its internal store. So 1 unit, again, just an arbitrary number. Then 5 units of energy are transferred by conduction from the pan to the butter due to a temperature difference. So this is actually the pathways. How much was added in or being transferred in? 5 units. So as a result, we have a total of 6 units, okay, of the internal store of the butter. Next, energy transferred by propagation of wave or the movement of wave. So wave is now helping to transfer the energy. Okay, so a girl is feeling warm and starts to perspire after kicking a ball in an open field on a sunny day. So electromagnetic waves, which is your infrared waves from the sun, this will cover in next few chapters under waves. Okay, so from the sun interact with the skin of the girl to create a sensation of warmth. So when the girl first steps onto the field, the system, which is the girl, has energy in the internal store. So again, we just use one unit. And based on the whether cloudy or not, we have 3 units of energy being transferred by propagation of electromagnetic waves. So this is the pathway, okay, and this is being transferred to the internal store of the girl. Okay, so as a result, the girl will have 4 units, right? Next, energy transferred by propagation of wave, mechanical sound wave. Before that, it was electromagnetic waves. Okay, so light falls under EM waves. Okay, infrared as well. Okay, total there are 7 components of the EM waves. But now we are talking about mechanical sound wave. So sound is a mechanical wave. Now sound is heard every time a boy hits 2 cymbals together. So the cymbals vibrate to and fro. When they are hit, this causes the air particles next to a vibrating cymbals to vibrate to and fro to produce sound wave. Energy is transferred by the sound wave to the boy's eardrum. So the boy's eardrum is the object that we are looking at. Okay, so initially the eardrum of the boy is not moving, right? It only moves when there is air particles vibrating and then transferring this energy to the kinetic store of the eardrum, so the eardrum can move. But before that, it wasn't moving. Okay, so every time he hits it, right, then there will be some energy transferred by propagation of mechanical sound wave through the air, and this gets transferred into the eardrum of the boy, which is the kinetic store of the boy. So 5 units will be present, or 5 units of energy is being transferred to the kinetic store of the boy, the eardrum of the boy, and then it starts vibrating, and that's where the boy starts to hear the sound produced by the cymbals. Okay, so again we talk about pathways. We talk about the kind of energy that's being transferred to the stores, and we also need to mention the owner of the stores. Okay, so this is how you would describe the energy transfer. Okay, energy transfer electrically by electric current. When a switch is closed, the bulb lights up. Now, the battery has energies in a chemical potential store. So, an electric current flows in the circuit when the switch is closed. So, the flow of electric current increases the temperature of the filament in the bulb and causes it to light up. So, now the system is the bulb. So, before that, it has a certain amount of internal energy before the switch is closed. After the switch is closed, we see that there are 4 units of energy transferred electrically from the chemical potential store of the battery. So now take note, we don't talk about the electrical energy because it is no longer in the syllabus, or the syllabus has changed, right? It is transferred electrically. Okay. So I say again, 4 units of energy are transferred electrically from the chemical potential store of the battery. Where to? Into the internal store of the light bulb. Okay, but as the 4 units of energy are being transferred to the internal store of the bulb also heats up. Okay, and there will be 2 units of energy transferred by light and infrared waves to the surrounding. So that is the whole purpose why we use a light bulb, right? We want to see, okay, although we don't want the bulb to heat up, but it does heat up, and energy will be transferred by the infrared waves to the internal store of the surrounding. Okay, so these 2 will be transferred to the internal store of the surrounding. Okay, so in the end, only 2 units of energy are being transferred to the internal store of the bulb. And so if you were to touch the bulb now, it will feel hot. Okay, one more example. Okay, in this case we are looking at the hammer. So the hammer is raised high up. So in the initial state, when a person raises the hammer above the ground, there is energy in the gravitational potential store. Okay, so because recall that gravitational potential store, energy in the gravitational potential store depends on its location or position above Earth. Okay, so there are 4 units of energy in the gravitational potential store. Okay, and I'm not just letting go of the hammer, I'm actually applying a force, okay, to move the hammer down, okay, together with the gravitational attraction. So 1 unit of energy is transferred mechanically due to the work done by the force of the person's arm in driving the hammer downward. Okay, so it will be different if I just let the hammer drop, so it will just have 4 units of energy. Okay, but now if I have this 1 more additional unit of energy due to me applying a force mechanically, okay, transferring the energy mechanically, the hammer will have 1 more unit of energy in the kinetic store, right? Because my purpose is to drive the nail down, and if the hammer moves faster, right, at a higher speed, then the nail will be driven down more. The energy that's being transferred will be more. Okay, so we continue. Okay, at part 2, okay, diagram 2, the initial amount of energy as the hammer moves down before impact is 5 units, right? 4 plus 1. And 1 unit of energy is being transferred to the surrounding by the sound wave. It makes a sound when it hits, right? And 2 units of energy are transferred mechanically to the nail due to the work done by the force of the hammer on the nail. Okay, so this one is used to drive the nail down. So 1 unit, no choice, is transferred to the surrounding by sound wave. Okay, so 5 minus 1 minus 2, in the end we are left with 2 units in the internal store of the hammer, right? So the energy in the internal store of the hammer becomes 2 units, and yeah, okay, so this is how we describe the energy transfer. Now, of course, the numbers here, the number of units, it depends, okay? So you don't necessarily always have to talk about the numbers. Sometimes they just ask you what is the energy that is being transferred to the store and by which pathway, and also you need to remember to mention the store of the owner, who owns that store, okay? So that's success criteria A. Okay, for success criteria B, recall and apply the relationship for kinetic energy EK equals to half mv square and gravitational potential energy near the Earth's surface EP equals to mgh to new situations or to solve related problem. Okay, so this is the definition for energy in a kinetic store. It's energy of an object due to its motion. Okay, now take note, a stationary or zero speed object will have zero energy in a kinetic store. So this is the formula that you need to memorize. EK, which stands for energy in a kinetic store, equals to half mv square. Take note, this is a SI unit formula. That means everything must be in SI unit. But I can also tell you that for this chapter of energy, all the formulas are actually SI unit formulas. Okay, so a few common mistakes I see is sometimes students, they will omit the half. So they will memorize the formula as mv square. Okay, sometimes they will omit the square. Okay, so it becomes half mv. Okay, so common mistakes are like mv square, half mv, or sometimes they will half and then mv whole thing square. So all these are common mistakes. Okay, so SI unit for energy is joules, SI unit for mass is kg, and SI unit for speed is meter per second. Okay, from the equation we can see that for two objects of the same mass moving at different speed, same mass but different speed, the faster object will have more energy in the kinetic store, right? And for different masses moving at the same speed, the object of greater mass has more energy in the kinetic store. Okay, so meaning to say, if I have a motorcycle moving at 80 km per hour versus a lorry, versus a lorry which has more mass moving at 80 km per hour, okay, the lorry is actually more dangerous if it collides with a car rather than a motorcycle, because even though they are moving at the same speed, okay, but lorry has more mass, so it will have more energy in the kinetic store, and when it collides, it will transfer all this energy to the object that is colliding, okay, mechanically. So yeah, that's why lorries have speed limit. Okay, then object that is held above the ground has energy in a gravitational potential store. Okay, it's due to the position of the object above the ground. So the formula is EP equals to mgh, whereby EP equals to energy in the gravitational potential store, m is mass of object, g is gravitational field strength. For us, we usually use use 10, okay, because it's although it's 9.81, but 10 is easier for us in our calculation. So you have to read the question. H is height, and SI unit is meter. So again, this is a SI unit formula. That means usually the tester, they will set things like cm. Okay, the mass, they will be in grams. Okay, so you have to convert it to kg. You have to convert it to meters. Okay, so let's look at B1. A bullet of mass 20 grams. So underline, and this will be our mass. Okay, and since it has to be in SI unit, so it will be 0.02 kg. It's traveling at 300 meter per second, so this is our speed. So calculate its energy in the kinetic store, so it will be EK. So formula EK equals to half mv square. So don't forget the half, 0.02, then 300 square. Okay, so answer is 900 joules. Okay, so very simple. Now a girl lifts a school bag of mass 3 kg, so this is m. Okay, and because 3 kg is already in SI unit, we don't need to change anything, so m equals to 3 kg. Okay, from the floor onto her lap through a height of 0.5, so this is our h. So again, SI unit already, so we don't need to change anything. So what's the change in the energy in gravitational potential store? So it's being raised from the floor. Okay, so initially at the floor there is the EP is 0, right? Because we take the reference as of the ground as the reference, right? But now it's being raised up by 0.5 meters, so this is the height. Okay, so at this position of 0.5 above the ground, it will have a change in the EP, right? Because EP is based on the position above the reference ground. So EP equals to mgh. So 3 multiplied by 10 multiplied by 0.5. So it will be 15 joules. So if you identify all the numbers, right, and then if you have the correct formula, most likely you'll get your calculation answers correct. Okay, next, a car accelerates down a hill. So going down a hill, the EP will decrease. And if he accelerates, that means the velocity increases. That means the EK increases. So what happens to the energy in the kinetic store and gravitational potential store? So if you have analyzed the first statement, so you'll know that the energy in the kinetic store increases, energy in the gravitational potential store decreases because it is going down, right? So answer is D. Before 2 balls of mass m and 2m respectively roll down from inclined planes as shown in the diagram. Determine the ratio of the energy in the kinetic store of A to B as they reach the bottom point. So the mass for A is MA and it has HA. Okay. For B it is 2. Okay, sorry. I think I should write it as M A equals to M. Okay, MB equals to 2M. HA equals to H. HB equals to 2H. Okay, so initially at this height, it has energy in the gravitational potential store. Okay, but as it goes down to the ground over here, okay, because it has 0 height above the ground, so the EP becomes 0 and the original EP will be transferred to the EK. Okay, so we can actually calculate the energy that it has at the top. So EP of A equals to mgh. EP of B equals to mgh, but now the M is 2M, the G is still G, H is now 2H. Okay, so it will become 4mgh. So EP A will become EKA. Similarly, EPB will become EKB. Okay, so they want us to find the ratio of the energy store EKA over EKB will then be equal to mgh over 4mgh, right? This is how you do the ratios, right? And since mgh and mgh can cancel, so equals to 1 over 4, so equals to 0.25. Okay, so in physics, when we express ratio, we don't leave it as fractions. We always leave it to 2 or 3 SF. So take note of that. So answer is 0.25. Okay.